You are given string s with lowercase letters and 3 special symbols, plus a 0-based index k. Build result by scanning s from left to right, letters append, star deletes the last character if any, hash duplicates the whole result onto itself, and percent reverses it. Return the character at index k in the final result, or a dot if k is out of range. Example 1, append a, hash doubles to aa, append b to ob, percent reverses to ba, star pops to ba. Index 1 points at the second character, which is a. Example 2, c and d give cd, percent flips to dc, hash doubles to dcdc, star removes the trailing c, hash doubles again to dcd dcd. Index 3 lands on d. Example 3, z goes in, star clears the buffer, hash on empty stays empty. Index 0 is out of bounds on an empty string, so the answer is dot. If our input string executes repeated duplication commands, its final length can explode exponentially to a staggering 1 quadrillion characters. Trying to physically build or store a string this massive will instantly crash our system. We must find a way to pinpoint the kth character without ever building the text. While we cannot construct the actual text, we can easily track how big it would be. By scanning the operations forward from left to right, we record the history of the string's boundary size at every single step. Letters append and grow the boundary, hash doubles it, star deletes one slot, and percent flips content without changing the count, mapping out a lightweight blueprint of our virtual canvas. Instead of trying to push forward into a massive sea of data, we play detective. We plant our target marker directly onto index k at the very end of our timeline, and we work backward through our recorded history to trace exactly where that specific index originally came from. To pull this off, our detective needs a clear set of translation rules. First, if our target index k is at or beyond the final total length, we immediately return a dot, there is nothing to find. Otherwise we retrace backward from the final size, updating total length and k at every step, shifting k, flipping k, or leaving k alone while length catches up. Letters are the finish line, shrink length by 1 and return the character when k matches. When our backtracking detective encounters a duplication hashtag, we exploit symmetry. The right half is just a perfect mirror clone of the left half. If our index falls inside that cloned right side, we discard it completely and shift k back by subtracting the base segment length. At the same step, we have total length, undoing the duplication shrinks the virtual string back to the original half. Next, what happens if we backtrack into a percentage sign reversal? If a section of text was flipped upside down, the character at index k must have originally come from the exact opposite side of the block, so we mirror k across the current total length. Total length itself stays unchanged, only the index flips. What about the star backspace? When going forward, a star deletes a character, meaning that data was discarded and never made it to the final string. Our target index k is unaffected, but total length increases by 1, undoing the delete restores the string to 1 character longer. Our detective passes straight through without shifting k. We continue this backward journey, shrinking and translating our target index across every historical operation. The exact moment our index maps directly onto a raw, foundational character, total length drops by 1 and k matches, the mystery is solved. We return that letter, conquering a massive scale problem with simple index math. This walkthrough focuses on the reverse pass only. We deliberately skip the forward length scan. For example 2, we already know the final string has length 6 and our target index k is 3. We pick up right at backtracking from the end of the input string. We enter our backtracking phase. Our forward pass determined that our final virtual string has a length of 6. We set our target index k to 3, and we position our pointer at the very end of our input string to reverse engineer our way to the answer. At index 5, we hit a duplication hashtag. This doubled our string size, so we undo it by having our total length from 6 down to 3. Because our target index 3 falls into that duplicated right half, we shift k back into the original first half by subtracting our new total length. K becomes 0. Moving back to index 4, we encounter the star symbol. Since a backspace deleted a character during the forward pass, going backward means we must expand our total length boundary by 1, from 3 back to 4. Our index pointer k remains safely at 0. At index 3, we encounter another hashtag. We cut our total length in half once more, dropping it from 4 down to 2. This time, our target index 0 is strictly less than our new boundary, meaning our target character lives in the safe, original first half. K does not change. Next, we step back to the percentage sign at index 2. To undo this full string reversal, we flip our index across our current total length boundary. Subtracting our index from our maximum boundary index translates our target k from 0 up to 1. We step back to the letter D at index 1. Because it is a normal alphabetical letter, we shrink our virtual total length by 1, stripping that letter from our canvas. We check our condition: does our target index k match this new boundary size? 1 equals 1, meaning we have successfully cornered our target character. Our reverse tracking is complete. By mathematically peeling back the operation step by step, we successfully identified our character as D using constant memory. We return our result. Time is linear in n, the length of S. We scan once forward to count virtual length, then once backward to undo each operation. Every input character is handled in constant time. Space is constant, only total length, k, and a loop index are stored, never the expanded virtual string. Main routine process _str takes string s and 0-based index k. Start with virtual total length 0. Forward scan, walk each character left to right. Star delete only applies when the virtual string is non-empty. Shrink total length by 1 to undo a forward backspace. Hashtag duplicate doubles the virtual length. Multiply total length by 2. Plain letters append one character in the forward pass. Add 1 to total length for a lowercase letter. If k is at or beyond the final length, return dot. Return dot when the target index is out of bounds. Reverse scan, walk indices from the end back to 0. Read the current source character at index I. Undo a duplication by having total length. Divide total length by 2. If k sits in the duplicated right half, shift it left. Subtract total length from k. Undo a star by expanding total length by 1. Add 1 to total length. Undo a reversal by mirroring k across the block. Set k to total length -1 minus k. Undo an appended letter by shrinking total length. Subtract 1 from total length. When k matches the new boundary, return this source letter. Return the character at index I. If no letter claims k, return dot.